Welcome back to our Prompt Engineering Masterclass. If you've watched the previous lesson, you already know how Skeleton of Thought helps AI generate better long-form content. But today, we're going one step further and learn Program of Thought prompting. Today, we'll also learn another powerful technique called chain of density, which is used by AI researchers to generate incredibly accurate summaries. By the end of this lesson, you'll know exactly when to use each technique and how companies are already using them in real world AI applications. So, without wasting any time, let's dive in. Now, let's look at something that surprises many people. Most people think ChatGPT is great at mathematics, but that's not entirely true. Language models are designed to predict words. They are not calculators. They don't actually calculate numbers like a calculator does. Instead, they predict what the answer should look like. Most of the time, that prediction is correct, but sometimes it fails badly. Imagine asking someone to multiply two 12-digit numbers mentally. Even a human might struggle. Similarly, AI may produce a confident answer that is completely incorrect. Let's understand this with a simple example. Suppose I ask ChatGPT, arrange these numbers based on the sum of their digits. At first glance, this looks like an easy question, but think about what AI has to do. For every number, it must calculate every digit, find the total, compare all totals, then sort everything correctly. That's actually multiple logical steps. If AI tries to answer directly, it may skip one of these steps, and a tiny mistake creates a completely wrong result. That is exactly what program of thought does. Think of it like hiring two people. Person 1 tries solving a difficult calculation mentally. Person 2 opens Excel, writes formulas, checks everything, and then gives the answer. Who would you trust? Obviously, the second person. That's exactly what AI is doing. Instead of guessing, it writes code. Program of thought is much more reliable than normal prompting. Now you might be wondering, if AI writes code first, what exactly happens next? Let's see that on the next slide. Now let's understand the complete workflow. Curious? It's actually much simpler than it sounds. There are only three major steps. Step 1. AI receives the question. For example, what is the EMI for a 10 lakh rupees loan at 9% interest? Instead of immediately calculating, pause, AI says, I'll solve this using Python. Chuckles. Step 2, AI generates Python code. Something like at principal equals 1 million rate equals 9 years equals 20. Textured EMI formula. Notice something interesting. The AI is no longer guessing, it is programming. Exactly the same way a software engineer would. Step 3. The Python code executes. Now mathematics happens using the programming language, not through word prediction. The program calculates interest, monthly payment, loan duration, and finally returns 8,997 rupees per month. Now the answer is mathematically correct. No hallucination, no approximation, just correct computation. This is why modern AI systems like ChatGPT often combine language models, Python interpreter, or code execution engines. Together, they become incredibly powerful. Real-world applications include financial calculations, scientific research, machine learning, Excel automation, business analytics, data cleaning, budget forecasting, engineering simulations, retention hook. So now we know AI can write code. But how does it decide when to write code? That's exactly what we'll discover in the next slide, where we'll explore the amazing capabilities of large language models. So far, we've learned that program of thought helps AI solve mathematical problems by writing code instead of guessing the answer. But here's an interesting question. How does AI know when it should write code? Does someone manually tell ChatGPT, hey, this is a math problem? Or does AI figure it out by itself? The answer is modern large language models are actually smart enough to recognize the type of problem they're solving. Let's imagine you're talking to two different people. The first one is a novelist. The second one is a software engineer. If you ask both of them, calculate compound interest for 5 lakh rupees invested for 10 years. Who would you trust? Of course, the software engineer, because they know that calculations require formulas, not imagination. Large language models are trained in a similar way. They've seen millions of examples involving mathematics, programming, logic, science, natural language. So before generating a response, they first try to understand what kind of problem is this. Suppose you ask, write a motivational speech. The AI immediately recognizes this is a writing task, no coding required. Now imagine you ask, sort this list of numbers by the sum of their digits. This time, the AI realizes this involves calculations. Instead of relying on language prediction, it decides to write code. That's exactly what's happening behind the scenes. That's why AI feels so intelligent. It's combining language understanding with programming. Now you've seen how AI decides to write code. But what kind of prompt should we give the AI so it consistently follows this process? That's exactly what we learn in the next slide. Now it's time to learn something practical. Until now, we've understood the concept, but how do we actually use program of thought in ChatGPT or any other LLM? The answer lies in a carefully designed prompt template. Take a look at the slide. It starts with question. This is simply where you provide the user's problem. For example, find all prime numbers between 1 and 100 or calculate the EMI for a 20 lakh rupee home loan. The next line is where the magic begins. Answer this question by implementing a solver function. Notice that we're not asking for the final answer. We're asking the AI to write a function. Why? Because writing code forces the AI to think systematically instead of making assumptions. Then the template says def solver. This tells the AI, treat this like a real programming problem. From here, the model starts organizing the solution logically. It identifies the inputs, defines variables, applies formulas or algorithms, and prepares the final output. Let's understand this with a practical example. Suppose we ask, check whether a number is prime. Instead of replying, yes, 29 is prime, the AI generates something like def solver, open parenthesis n, close parenthesis, colon, return true. Once this code is executed, the answer is mathematically verified. This is far more reliable than relying only on natural language. Why the template matters? Prompt templates provide structure. Without structure, different AI models may respond in different ways. With a clear template, you get more consistent and predictable outputs. That's why prompt engineering isn't just about asking questions. It's about designing instructions that guide the model toward the best possible reasoning process. When building AI-powered applications, use templates for repetitive tasks. Use program of thought for calculations. Add few short examples for higher accuracy. Execute the generated code in a secure sandbox. Return only the verified result to the user. This workflow is used in AI coding assistants, financial tools, scientific software, and educational platforms. Program of thought is not just about generating code. It's about creating a repeatable reasoning process that produces accurate and trustworthy answers. We've learned how AI becomes better at solving problems. But what if your goal isn't solving math? What if your goal is creating the best possible summary of a massive article, research paper, or book? That's where our next technique comes in, chain of density prompting. And once you understand it, you'll never summarize long documents the same way again. So far in this masterclass, we've learned how to make AI think better and how to make AI calculate better. But here's another challenge. Can AI summarize a 100-page document without missing important information? Most people think summarization is easy. You simply ask ChatGPT, summarize this article. And yes, it gives you a summary. But here's the problem. A normal summary often removes details that are actually important. Imagine reading a 50-page research paper and the summary tells you only the conclusion. What about the methodology, the dataset, the limitations, the future scope? Those details are gone. That's exactly the problem that chain of density prompting solves. What does density mean? Think about a sponge. A dry sponge contains very little water. A wet sponge contains much more water without becoming much bigger. Chain of density works exactly like that. Each new version of the summary contains more useful information without becoming longer. The goal is maximum information in minimum words. Let's understand the diagram. Take a look at the slide. On the left, you have a huge article. Maybe it's a research paper, a legal document. Now, instead of creating one final summary, AI creates multiple drafts. First draft, very simple, only the main idea. Second draft, AI reviews the original article again. It asks itself, what important information did I forget? It finds 2 or 3 missing entities. Then it rewrites the summary. Third draft again. AI searches for missing entities, adds them, removes unnecessary words, makes every sentence richer. Finally, you have an incredibly informative summary. What are entities? The slide introduces an important word, entity. Think of an entity as an important piece of information. For example, imagine this news headline. OpenAI launched GPT-5 in San Francisco on July 15th. Important entities are OpenAI, GPT-5, San Francisco, July 15th. If your summary says, a company launched a new AI model, you've lost almost everything. Chain of density forces AI to include these important entities. The 5 rules. The slide lists 5 characteristics. Let's understand them one by one. 1. Relevant. Only include information that matters. Don't mention unnecessary details. 2. Specific. Instead of saying a company, say OpenAI. Specific information makes summaries useful. 3. Novel. Every new draft should add something new. Don't repeat old information. 4. Faithful. Never invent facts. Everything must exist in the original article. No hallucinations. 5. Anywhere. Important information can appear anywhere in the document, beginning, middle, or end. AI must search the entire article. Where is it used? This technique is widely used for research papers, legal contracts, medical reports, business meetings, YouTube transcripts. If you've ever used AI tools like Notion, AI, Perplexity, Claude, or ChatGPT to summarize long documents, you've already seen similar ideas in action. Chain of density isn't about making summaries shorter, it's about making them smarter. Every draft removes fluff and adds important information. Now that you understand the concept, let's see the actual prompt template researchers use to make AI generate these high density summaries. Now it's time to see how we actually instruct AI to create these rich summaries. This slide shows the chain of density prompt template. At first glance, it may look complicated, but once we break it down, it's actually very simple. Step 1. Give the article. The prompt starts with article. This is where you paste the complete article, report, research paper, or meeting transcript. Think of this as giving the AI the raw material. Without the full article, the AI has nothing to summarize. Step 2. Provide the current summary. Next comes summary. Notice something important. We are not asking the AI to create a summary from scratch every time. Instead, we give it the current version and ask it to improve it. This allows the model to build upon previous work rather than starting over. Step 3. Find missing entities. Now comes the most important instruction. Identify two informative entities that are missing from the current summary. Ensure those entities are relevant, specific, novel, faithful, and can be found anywhere in the article. Think of this as a quality check. The AI asks itself, what important details did I forget? Step 4. Rewrite the summary. Finally, the AI rewrites the summary. Here's the clever part. The new summary should be the same length as the previous one. So how does it fit in more information? By removing unnecessary words and replacing them with meaningful details. This is why it's called chain of density. Each revision becomes denser without becoming longer. The template teaches AI to review its own work and improve it step by step. That's a powerful idea that can be applied far beyond summarization. So, does this process actually work in practice? Let's look at the research results. Final comparison. Let's compare the two techniques you've learned today. Program of thought, best for math, coding, and logical reasoning. Chain of density, best for high quality summaries. These aren't competing techniques, they solve different problems. Knowing when to use each one is what makes you a better prompt engineer. Congratulations! You've just learned two advanced prompting techniques used by AI researchers and professional developers around the world. Let's quickly recap. Program of thought improves mathematical and logical accuracy by writing and executing code instead of guessing. Chain of density creates information-rich summaries by iteratively adding important missing details. These techniques are already being used in AI products, coding assistants, research tools, document summarizers, and enterprise applications. Here's a challenge for you. Open ChatGPT or your favorite LLM today and try each of these prompting techniques on a real task. Compare the results. You'll immediately notice the difference. If you found this lesson valuable, like this video, subscribe for the next masterclass, and in the comments, tell me, which technique are you most excited to try? Program of thought or chain of density? In the next session, we'll explore even more advanced prompt engineering strategies that can take your AI applications to the next level. Until then, keep learning, keep building, and I'll see you in the next class.